The 1970s were a period of significant geopolitical tension. The Cold War cast a long shadow across the globe. Military powers were locked in an arms race, advanced technologies were rapidly developed and deployed. This had a direct impact on the evolution of military aviation. Jet fighters were becoming increasingly sophisticated. Israel, a nation at the heart of a volatile region, faced unique security challenges. Surrounded by hostile neighbors, Israel relied heavily on its air force. Maintaining a technological edge was not just important, it was essential for national survival. The Israeli Air Force, or IAF, had a proven track record of innovation. They adapted and upgraded their aircraft to meet specific operational needs. The IAF had already adopted the American-made F-4 Phantom II. This was a powerful supersonic jet fighter bomber. The Phantom gave the IAF a critical advantage. But the rapidly changing landscape of aerial warfare meant that standing still was not an option. New threats emerged that demanded a new generation of capabilities. The emergence of the Soviet MiG-25 Foxbat was one such challenge. It would set in motion the development of Israel's own Super Phantom. The Soviet MiG-25 Foxbat sent shockwaves through Western intelligence circles. This high-altitude supersonic interceptor was shrouded in secrecy. Its capabilities were initially overestimated. This caused concern among Western military planners and their allies. The MiG-25's incredible speed and operational ceiling presented a new and significant threat. For Israel, the threat was particularly acute. The MiG-25 was deployed to Egypt and Syria. These were frontline states in the ongoing Arab-Israeli conflict. The IAF needed to be able to counter this new threat. They also needed to gather intelligence on its capabilities and deployments. This need for up-to-date information on enemy activities brought the issue of aerial reconnaissance into sharp focus. Existing reconnaissance platforms were deemed insufficient. They lacked the range, altitude, and speed to effectively operate against the MiG-25. Israel needed a new solution. It had to be capable of penetrating heavily defended airspace. It also had to be able to gather high-quality imagery from altitudes that kept it out of harm's way. This marked the beginning of Israel's quest for a dedicated high-altitude, high-speed reconnaissance platform. This would culminate in the development of the F-4X. The IAF's initial forays into high-altitude reconnaissance were marked by both innovation and limitations. The G-139 reconnaissance pod, developed through a collaboration between Israel Aircraft Industries, or IAI, and Elbit, was a key early development. The G-139 was a modular pod. It could be fitted to the centerline hardpoint of the F-4 Phantom. It housed an array of cameras and sensors. These were capable of capturing high-resolution imagery from significant distances. While the G-139 represented a step forward, it had limitations. Its bulky size and drag significantly impacted the performance of the F-4. This reduced its top speed and maneuverability. These were serious drawbacks in a combat environment where every second counted. The IAF needed a solution that enhanced rather than hindered the Phantom's capabilities. This led to a series of experimental projects aimed at pushing the boundaries of aerial reconnaissance. The IAF's engineers and test pilots were not afraid to take risks. They were driven by a pressing need to outmaneuver and outsmart their adversaries. One such project, codenamed Skyburner, would prove to be particularly significant. It laid the groundwork for the F-4X. Section 4. Pushing the limits. Project Skyburner and Aerial Dominance. Project Skyburner was a testament to the IAF's commitment to pushing the envelope of what was possible in the air. The project's goal was to adapt the F-4 Phantom for high-altitude, high-speed reconnaissance missions. It focused on enhancing the aircraft's capabilities while minimizing the performance drawbacks seen with the G-139 pod. Engineers experimented with a range of modifications. These included removing unnecessary weight, streamlining the airframe, and improving engine performance. Test flights were conducted under the utmost secrecy. They involved pushing the modified Phantoms to their absolute limits. The data gathered during Skyburner was instrumental in shaping the F-4X concept. One of the key lessons learned during Skyburner was the importance of integrating reconnaissance systems into the F-4's design. Rather than relying on external pods, the IAF recognized the need for a more streamlined and aerodynamic solution. This philosophy would guide the development of the F-4X. The lessons learned from Skyburner were directly applied to a subsequent operation codenamed Peacejack, which would prove to be the true genesis of the F-4X program. Section 5, Peacejack, a technological leap. Operation Peacejack took the insights gained from Skyburner and applied them to a real-world operational environment. This highly classified program involved converting a small number of F-4E Phantoms for advanced reconnaissance missions over hostile territory. The modifications were extensive. They involved a range of technological innovations. The Peacejack Phantoms were equipped with a new generation of cameras, sensors, and electronic warfare systems. These were all seamlessly integrated into the aircraft's structure. This minimized drag and maximized performance. The Peacejack Phantoms were also fitted with more powerful engines. They had enhanced fuel systems for extended range. This allowed them to reach higher altitudes and sustain supersonic speeds for longer durations. The success of Operation Peacejack proved the viability of a dedicated reconnaissance variant of the F-4 Phantom. It paved the way for the formal development of the F-4X. Section 6. The Phantom's Evolution, Envisioning the F-4X. The F-4X was envisioned as the culmination of the IAF's experience with high-altitude, high-speed reconnaissance. It was to be a purpose-built platform. It would incorporate all the lessons learned from previous projects. The F-4X design went beyond simply adapting an existing airframe. It involved significant structural changes and technological advancements. The proposed modifications were extensive. They included a new elongated nose section to house an advanced suite of reconnaissance sensors, a redesigned cockpit with side-by-side seating for a pilot and a dedicated reconnaissance systems officer, or RSO, upgraded engines for increased thrust and fuel efficiency, advanced avionics and electronic warfare systems for enhanced situational awareness and self-protection. The F-4X was expected to be capable of sustained supersonic flight at altitudes exceeding 70,000 feet. Its advanced sensor suite would have provided unparalleled reconnaissance capabilities. It could operate day or night in all weather conditions. However, the ambitious F-4X program would face unexpected hurdles. Export considerations and international politics would lead to the development of a modified variant, the RF-4X, which would ultimately be adopted by other nations.